Let me know when the recording is ready.
Oh yeah, channel 0 is kind of like an NSA channel, yeah. Let's just pretend that. It's a feature, not a bug.
Oh shit, I'm gonna reload.
Yeah, Quad, I'll boost my mic.
I'll be back.
Oh, people are getting microphones? What the hell?
Alright, how is this for volume? Sounds good.
I can hear you.
Yeah, audio's good.
Hey.
What the fuck did I just do?
Why can't it go up? It's because I was using the wrong thing. I always use the wrong thing. Ow. 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 Ow.
Don't do that.
I didn't try to do
Names
that.
go upside down too.
Ah.
Oh my goodness. Oh my gosh.
Whoa.
Bless.
It's good. It's fun, right?
Yeah.
That's crazy.
I like your skin.
Wait, there's
Hey, all.
jukebox music playing on channel 15?
We're getting started, so please don't talk. Thanks.
Alright, just gonna check one more time that the recording is all good, and then we can get started. Alright, that sounds great. Then we'll get going. Semver by Tom Preston Werner is quite possibly the worst massive multiplayer incremental game released since the IRS 1040. Despite its infamy, it has been one of the most impactful releases in its genre, and remains one of the most widely referenced and replayed to this day. Semver, or semantic versioning, is the oft-neglected formal spec for versioning releases in software. Hypothetically, the changes in the different parts of a version number, for example, 1.4.7, should be indicating to developers and users what kind of changes have occurred. In practice, the biggest number changes when big things happen, or when you need to market a brand new feature. But, hypothetically, if you release software intended to be consumed by other developers, as long as that first number doesn't change, good faith consumers should never have to change what they've written. Oh, hi, I'm Emmy. I develop several mods, mostly libraries and APIs with a UX component, such as EMI or trinkets. My presentation today is fairly technical, but I will be attempting to make up for it with a dash of whimsy. Today, I am going to teach you all how to lie and how to get away with it. Not to a person, that would be mean. I'm going to be lying to a computer. Computers, I guess, including all of the computers currently running in this pack and hundreds of thousands of other computers in the past up to present. I will be preemptively recommending that you do not follow in my footsteps with what I talk about today, unless of course you know more about it than I do, in which case, I'm not your mom. With that out of the way, earlier this year, I was spending time working on making my mod, EMI, cross-platform. If you're curious what EMI is, open your inventory. This process involves several steps. Of course, I need to convert my content to work with Forge's systems. That means ingesting my mixins, using new events, communicating with Forge's APIs, and so on. This is a somewhat known process, and there have even been talks in the past about it at last year's BlanketCon. However, I had a problem. EMI's API was designed in a small number of places to use Fabric's API types. This decision was done because I had no intention of ever porting EMI to Forge when I initially developed it. But that obviously changed. In order for EMI's API to be usable on Forge, I need to change these symbols to use different types, be it from EMI or vanilla. In addition, I need to move the methods for creating stacks out of Fabric types like fluid variants to Fabric-specific classes, and create equivalents for Forge. The latter half of this is much easier. However, for the former, This is a problem. According to Tom Preston Warner, because it would be a breaking change. EMI supports several Minecraft versions at once, currently 1.19.2 up to modern day. And ideally, EMI on Forge should support more versions than just the most current if it's easily possible. If I just had different versions of the core API methods, like this for Forge and Fabric, XPlat mods, or cross-platform, that depend on EMI's loader-agnostic artifacts are going to run into serious issues, because there is not going to be a method where there needs to be one. If I remove or change these methods, mods written with older versions of EMI will crash, and devs will need to update, which is something I find unacceptable for my API. The solution is, of course, obvious. Make the breaking change in the API, and don't break the ABI. To discuss this, I need to make a pit stop on the two types of library dependencies in code in general. There are statically and dynamically linked libraries and dependencies. A statically linked library is included with your program and will not change unless you change it. For all purposes, it is your program. A dynamically linked library, on the other hand, is not included with your program. The user is expected to download it, or the system you're running on your program can change what you bundled. Minecraft modding is a dynamically linked ecosystem. If a mod depends on EMI's API, EMI can be updated and changed by the user to a later version with newer features. And mods should be expected to continue working, at least within the same Minecraft release. This is what Semver did not prepare you for. See, there are two types of cross-version compatibility when it comes to dynamically linked dependencies. If a library changes the name of one of its methods, your old code is going to break, because when you update, the old name doesn't exist anymore. However, if a library changes one of its types from a float to, say, a double, or some other type that can be implicitly converted, if you do change that dependency, your code will look like it works fine. This is not actually true, though. When you update the dependency, the compiler produces different bytecode from the code because the dependency signature has actually changed. As a dev, you didn't have to do any work, but if someone tried to load your old release with the library's new release, it'll crash because it expects the method with a float. As an API developer, this is something you need to be careful of. Moving methods around or changing signatures in ways that seem compatible might not be, so you need to keep in mind how your code is compiled to bytecode when you want to work with code like this, especially when interacting with other libraries. This concept is called ABI compatibility, or less confusingly, binary compatibility. So, the concept is simple. Instead of changing types or moving methods causing a binary break and no API break, we want to do the reverse. I'm fine breaking EMI's API one time, specifically for 1.0.0, as long as the binary compatibility remains. The question becomes, how do I remove methods from my API, but let things continue working as normal as if they're still there? A naive programmer may suggest something like making these methods private, but the Java runtime actually does validate visibility of methods, and the methods themselves will be trying to load the problematic Fabric classes on Forge, so this isn't actually a solution. Fortunately, we modders have a tool for this. Mixin is a library for annotation-based runtime bytecode modification in Java. As a crash course, when the Java runtime wants to load a class, it doesn't need to just grab a file that's sitting around in your jar files or programs. You can step in and give it a fake file you just made from code. For our use case, you can take a file that exists and run some modifications on it. This process in Minecraft is often referred to as core modding and is extremely prevalent. Mixin is A simple example of this is Fabric's access wideners. A developer can put a small file in one of their mods that specifies some private things they want to be public, so they can interact with them. At development time, changes will be made so the compiler thinks the symbol is public, and at runtime, Fabric will read the access wideners and change any class that is loaded so that their symbols are made public. Mixin is a bit more complex than this. It gives developers utilities to make common code changes simply, without having to manually mess with the bytecode manually. For instance, you can overwrite or replace a method with your own code to change what, say, a block or an item does. Or you can inject into a call to a method of yours inside some vanilla code. The limitations for common use case are pretty minimal, and this system is what mods use to do interesting or complex behavior a majority of the time. The best part is there is very minimal performance cost using runtime bytecode manipulation. The only time the class needs to be changed by mixin is when it's loaded, which is something that only happens once after the game is created. Once a mixin is applied, it's just normal code that's running as fast as normal code can, being optimized by the JVM like normal. And even the class load time is extremely minimal. It's a very fast process overall. The BlanketCon 2023 pack you're all playing on has several thousands of individual mixin files making changes to the game, each with potentially dozens of injections or modifications. I go over this description not just for people who have never written mixins, but also for the developers who use mixins and don't actually know how they work on a deeper level. This is surprisingly common among developers. Mixins can make the process almost opaque at times. So then, if mixin or some other runtime bytecode manipulation tactic can change a class at runtime, that's what I want. The idea is simple. In my API, I remove all the problematic symbols, and I move all the symbols I need to make my API break for XPlat and 1.0.0. While I'm at it, I can clean up some code issues that have been causing me some headaches. At the same time, I write mixins instead of on Minecraft classes on my own classes, so that when my classes are loaded on Fabric, it puts all the things I just removed back using runtime bytecode manipulation. Sound simple? Well, it's not, but don't worry. Of the 7 deadly sins, sloth is the only one that does not impact how I write core mods. Let's consider some of the easier changes. Most simple, I need to remove these methods. Fluid variant and item variant are Fabric API types and won't be present on Forge. So I remove them here, and I create a mixin to EMI stack. All I need to do is put the method in here, and mixin will copy it to EMI stack. No annotations needed. Not every dev knows this, but this is one of the core features of mixin. Any methods or fields that you write are just copied into the destination class, possibly renamed. Every injection method are just copied in as well. A lot of people assume their code is getting put inside of the method they're injecting into, but the only code that is getting added is done by mixin itself to call your method. So I actually misled you. We're not supposed to go forward yet. This is going to be the first of several instances where mixin This is going to be the first of several cases where mixin, in trying to patch footguns, prevents useful behavior that I want. In this case, you're not allowed to have methods in mixins that are both public and static, because then you'd be able to write code that can call these methods if you're not properly educated on how they work and try to load the mixin class, which is something that's prevented. So we're going to have to use a little trick. Mixin has a concept called a mixin plugin, which can give you code control of what mixins are loaded and how they target classes. In addition, what we will be using is hooks to add your own transformations. Going forward, mixin is going to be used much less, and most of these changes are going to be written manually. So, easy solution. Add an annotation, say @forcePublic, and put that on the private static method in my mixin. Mixin will copy that method and its annotation into the destination class, and the method for applying changes after mixins will run, and I can look for things that use this annotation, and I can just change the visibility myself, avoiding the step where mixin actually checks and gets angry if I have public static additions to classes. Voila, no more complaints, everything works. I can leverage this strategy to replace all of the static API methods I need to remove in EMI stack and more. The next problematic class is comparison. EMI lets stacks have comparison methods that determine their unique identity. For instance, all instances of Minecraft Stone are the same, but instances of Minecraft Potion should be compared by the potion effect they have. The initial release of EMI had a pretty limited and annoying implementation of comparison, and it references the fabric tri-state type, so I need to replace it. If I'm breaking it already, I might as well replace it with something good. In particular, I just want to remove the builder pattern and allow for completely custom predicates. Removing the tri-state methods is easy enough. Since they're not static, I can just make them public and put them into my mixin, and they'll copy over just fine. Same thing for the public tri-state fields. In addition, since I'm removing them, I'm going to have to inject into the constructor of the comparison and assign the fields, which is easy enough. For the builder, well, I just want to remove it, but I can't do that because I need to mutate it at runtime. Of course, I could have gone for another strategy where I whip up the class from midair, but it was easier to go with the simpler solution. I just make a private class with nothing in it, and at runtime, I put everything back. I want to remove everything because I don't want it showing up in my Java doc, even if it's private. The first and simplest problem is visibility. I can just use the force public annotation from before to make the class public. Solved. A second problem is the fact that Java is going to put an empty private constructor in my bytecode, which I don't really want. It's not actually going to cause any problems, but I might as well get rid of it. So I added the @strip constructors annotation, and that is solved as well. Third, this is a builder type, so I need to reference the builder to return it from all of the methods. However, I just said I'm going to make it private. I could access widen it, but that could be transitive and ruin the whole point of making it private in the first place. And in general, I'm going to want a flexible way of referencing private symbols. Introducing the annotation that will be carrying most of my changes, @transform. @transform is going to be my general case, do what I say, not what I did button. It can change the name of any symbol, modify the descriptor, which includes field types and method signature, the visibility to replace force public, and at last there's a field for flags that I'll be using later. Visibility is simple. I had already done that to make things public, but I just need to make it able to accept different values and read from the annotation instead. In practice, I never did anything but public. Name is a little bit harder. See, it's easy for me to just change the symbol's name using my transformer when I detect the annotation, but then I run into the situation where I may have referenced it from another method in my mixin, and I'll also need to change the references there, so I need to do a pass over. This is true for descriptors as well. It's easy enough to change, but all the times the method's reference needs to be changed too. I can simply store the original value when I read an annotation and iterate through all bytecode instructions inside of all the methods and replace them if they match the name and descriptor. Now you might be wondering, if I change the descriptor, how do I change all the types that are referencing it? If I change a parameter's type from string to item, add some integers, and change the return type, how does it handle it? That's a very easy question. It explodes. In the case I will be utilizing it, I'm not touching anything. When I change the return type from comparison builder to comparison, it's just going to work. Because I'm pushing this to the stack, the return type just happens to match. At runtime, when it tries to verify it, it'll work. Looking back on this, I'm not actually sure if Mixin would have handled this and if this endeavor was necessary for the specific method, because I didn't even try it. But I needed this annotation anyways later, so I might as well have done it. I can also utilize @transform to add constructors to my own classes. If you were to join a Mixin support channel and ask how to add a constructor to a class, you might get arrested. In Java, a constructor is just a method with the name init surrounded by angle brackets with a return type void. So all I have to do is add utilize @transform to rename one of my methods to init, and everything's great, right? I'm sure the tone of that question inspires great confidence in my suggestion, because no, actually, that's not it. If I do this, it'll crash because I'm not invoking super. In Java, classes need to call their superclasses constructor in their constructor. In Java code, this has to be the first line of your constructor. But in bytecode, this concept doesn't make sense, and you can call it from wherever you want. But wait, Comparison Builder doesn't have a superclass. Why is it breaking? Technically, its superclass is object, and I still need to invoke it. The Java compiler implicitly sneaks this call into your code, but I'm not writing a constructor. I'm writing a normal private method and changing it to be a constructor at runtime. I'm going to have to call the super manually. This is a problem, though. The Java compiler doesn't let you call init wherever you want, and this is not a constructor at compile time, so I can't just add super. We will have to add my second biggest trick, add invoke target. The way this functions is pretty simple. I write a method in my mixin and annotate it with @invoke target. The annotation defines what method I want to actually invoke, in this case, object.init. I'm going to make sure the parameters are correct so the stack lines up, but in this case, init takes and returns nothing, so it's simple. Then, when my mixin is loaded, I go through and remove all of the methods tagged with invoke target and keep track of what they were. Then, just like renaming methods before, I can go through all of the instructions in the class and see if anything called the previously existing invoke target methods. If they do, I replace the invoke instruction with the real instruction specified by the annotation, using its owner, name, and descriptor. It's worth noting that the constructor invokes need to use the invoke special instruction instead of invoke virtual, which is what normal instructions would do. The annotation supports setting this, but it's also just hard-coded to work for methods named init, because that's the only way you'd ever invoke them. And just like that, I can use this code to add a new constructor, which is public, and people can call, except they can't because it's added at runtime, except they can because it used to exist in an old version of my API. Does that make sense? We're not done. The comparison class itself had a copy function, which created a new builder. This is a problem, though, because the builder class is now private, and I need to return it. Once again, I'm going to have to use @transform to change the signature of my method. I'll just define it as object, and at runtime, it'll change to be comparison.builder like before. Then I'll need to create a builder using the constructor in the private class that I just removed. This almost seems like a use case for invoke target, but there's a problem. If you were unfamiliar with what constructor bytecode looked like, but understood a bit about Java, you might have been confused to learn that constructors return void earlier. That is, seems like a use case. If you call the method, you get nothing back. But there's a problem. Shouldn't you be getting back the object you just made? Well, if this actually doesn't make a ton of sense. Constructor bytecode looked you had to pass an object to even invoke the constructor. Most languages like Java hide this. Return void. But when you call a non-static method, that is, the first parameter you're passing is actually the object itself. Shouldn't you be getting when you use the keyword this or otherwise reference any non-static builder method, you're actually referring to that first hidden parameter sent to every method. In bytecode, it's the first thing you push to the stack before any of the normal parameters. So if I try to invoke this constructor, I'll need to first make a builder object. In bytecode, this uses the new instruction. In typical fashion, a construction of an object is using new, then calling dupe, then pushing all of the parameters to the constructor needs to the stack, then actually invoking the method. The dupe is used so that there are two references of the object on the stack instead of just one, because one of them is going to be consumed when calling the constructor. And when you're done, you want to be left with the object you just created. Okay, so let's just add a special invoke target type. I can already pick what type of invoke I want to do. Let's just make one that does this new behavior for new. When I was describing this process earlier, you may have noticed that the parameters were put on the stack after calling new and dupe. If I'm going to be replacing the bytecode for a normal method with a new, I need to put those new and dupe opcodes before the first parameter on the stack. And that is actually pretty difficult. See, there's nothing that says all the parameters are just put there normally in order. If you've written code, you've invoked a method to get a parameter for another method before. The stack, halfway between putting the next method's parameters on the stacks, we'll start putting the parameters for another method on the stack, then invoke that method to get the parameters for the outer method call. It's a bit confusing. It's not unsolvable, but I really didn't feel like solving it, so I created a simple hack. When I create a constructor at invoke target, I'm going to have at the start an object parameter that's just a placeholder for the object we need to create. And it will return an object as a placeholder for the object we're left with after invoking the constructor created from the dupe. When I call the @invokeTarget method, I'm going to pass a constant field, mixinPlaceholder.newDupe. In my transformer, when I'm replacing an @invokeTarget call, if it's a constructor, I'll go backwards through instructions until I find the load field instruction that references the static field newDupe. I'll delete that instruction, and using the information from the invokeTarget annotation, replace it with a new and a dupe instruction. At this point, the stack is going to correctly be in the state it needs to be, and any code that deals with the invokeTarget method will just work. So there's that. Using this, I can now implement the comparison.copy method that invokes a constructor. I also need to invoke the private comparison constructor in the builder, so I'll just use the same procedure there. Let's look at another example. Here is the inner class, emiStack.entry. The entry system used to represent a more concrete type that could be associated with a stack. On Fabric, it was using item variants and fluid variants, fabric types, and the system was mostly vestigial, so I wanted to just get rid of it. Here uses the same process as before. Remove everything from a class, then put it all back with the transform at @invokeTarget. In this instance, I use the flags field for the transformer to do stuff like make a final field or make a class abstract. But this is a special case. This was a superclass for several other types that I'll be doing this with, so I need to add a new annotation. Introducing @extends. It should be self-explanatory, but all this does is change the superclass of whatever I'm mixing into. This is really simple in Java. It's just a one-line change in the transformer. You just have to make sure you're playing nice and overriding all of the correct methods if you're overriding an abstract method or an abstract class. There is a reason that Mixin doesn't let you do this. @invokeTarget lets you specifically say super instead of specifying your superclass, and it'll figure it out for you because it can know it during the transformer time. And it layers fine with @extends. So the constructor is calling is working perfectly, and it's extending the class as I want. Here's what the final fluid emiStack mixin looks like. There's a lot going on here, but it's all just utilizing the stuff I've already discussed. @transform, @invokeTarget, and some standard mixin @inject. I did mention it earlier, but it's worth saying again that transforming the type of a field like this and the parameter or the return types of method just kind of works. Nothing extra had to be done, because all the stuff will be correct on the stack at runtime. I've shown off a handful of the mixins in EMI, particularly those that craft a compelling linear narrative, but there are about a dozen like this, relatively large in size, re-implementing the handful of parts of problematic EMI API. It's not worth going over them all, so there's just one thing that I had left that I wanted to do. I left some public static final fields here, and they're accessible in my API, and I don't want that. I'm already breaking stuff, and people really shouldn't be touching them, so I'm just going to put this as a breaking change in 1.0.0 while I'm here anyways. Except this totally doesn't work. Mixin won't let you have static final fields like this in interfaces, and it can't be a non-static field because it's an interface, and interfaces can't have non-static fields. And Mixin won't let you mix into an interface with a normal class to add fields normally, and even if I could, it wouldn't let you have public stuff, so I would need to transform it. This was really annoying because it was the last thing I wanted to do, and it would require so much effort to resolve for a really simple, tiny thing. Either I hardcode the transformation and give up, or I make a whole complex process of invoking a method like mine during class init. I actually tried to do something like this, returning the values to be set in new fields, and it just crashed, and I didn't feel like figuring out why. Eventually, I gave up and went with a copy procedure. You annotate a method, it destroys the method, and it makes fields that copy some other field's value during class init, which I just happened to have lying around in my implementation classes, so that was fine. And that's that. EMI was ported to Forge. I made a breaking change to my API without making a breaking change to my ABI. It's actually still in the 1.20 version of EMI, despite being totally unneeded, because I've never released a version below major version 1 in 1.20. I just haven't felt like taking it out because it took so much work to make. Due to this, I'm proposing a two-dimensional version number system I've been working on called Semver2, under which EMI is now in version 1.0.4, 0.8.3, 20.1.5. I'm anticipating this receiving large-scale adoption among both hobbyists and professionals. With this, I can go to my closing thoughts. So, was this a good idea? Yes, it solved a problem, and it was also really fun to do. I knew a lot about runtime bytecode manipulation going into this, which is what made the whole project possible, but using it in a real production environment with EMI, with real consequences, was really cool. Do I actually suggest anyone do this? I joked no at the start, but I do honestly think this solves a problem for the dynamically linked ecosystem of modded Minecraft. Large-scale changes like this are perhaps excessive and prone to breakage. I would strongly hazard against trying to leverage these strategies unless you basically already knew all the things I explained today, and how to test that your changes are working correctly. Runtime bytecode manipulation is powerful, but it can be hazardous. Do I plan on using this moving forward? A bit. There are sometimes situations where you make a bit of an oopsie and have to commit to a bit of an annoying API. Maybe you published a new version and you had the wrong return type on something. It's useful in cases like this to make small, non-compile breaking API changes and not to break the ABI in ways that developers won't notice. Say, changing a return type from void to something else, and keeping the void version around only appearing at runtime. It could also be useful in situations where you want to add a new method to an interface, but that would technically be a breaking change because it wouldn't be implemented anywhere else. You can add an empty stub in the interface and then mix into the interface to add a default implementation as a fallback, so that developers that use the new API are forced to implement it, but old developers can still have their code work. And finally, was Mixin the right tool for this? No, but no other proper tool really exists. Doing something like this with Mixin was fighting it the entire way to let me do what I understood, as it tried to prevent me from foot-gunning myself. I understand the value of guardrails, but I in particular am interested in investigating the forested rock wall under a mountain road descending at a speed of several dozen kilometers per hour. In this way, Mixin isn't great for me. I suppose we have time for questions, so if we want to open it up, we could do that. Also, I have no idea how to accept questions. Oh, there's one thing in the chat. I guess I'll answer that very quickly, even though we're supposed to be using books. Asakek asked, do I plan on releasing my annotations framework as a standalone thing? No, only because I don't want to maintain it. The current state of all of these annotations I showed, especially at transform and at invoke target, will explode your JVM immediately if you use it even slightly wrong. And even if you use it right, maybe it'll explode. I don't know. I don't feel like debugging these things. It's a solution to a problem rather than a proper product that I want to maintain. So yeah, I don't plan on releasing this at all. Okay, yeah, so I have some questions on my slide now. Is there a way to include these extra mixing annotations in our project so that the system seems cool and I'd see some uses for them? So yeah, what I already said, no, there is not. I'm not going to be releasing this publicly. but I don't have any claim on the concept of modifying classes. This is just kind of a thing you can do with Mixin. So I'm sure there are existing libraries that may have annotations that do some similar things, or they could re-implement some of these features. In the end, there's only 4 annotations that EMI uses, which is strip constructors, which is a very specific thing that could be more targeted to say remove specific methods. There's transform, which does a variety of transformations. There's inject target or invoke target, which replaces an invoke with an arbitrary target and can even handle constructors. And there's extends, which is just extends. I'm sure there's a library that has extends, and I wouldn't be surprised if there's a library that has transform. I would be kind of surprised if there's a library that has an invoke target annotation, though. There's another question. Now that we have mix-in extras, are we going to get cursed mix-in? From me, no. Someone can make it, though. How does Semver2 handle mappers like HughCL? Leo, you're going to have to tell me in chat what system you're referring to. And then I can answer this question. If you mean the... Yes, it's a joke about the Game Boy Color. I just wanted to make sure you were talking about the Game Boy Color. It doesn't handle it, just like the Game Boy Color. You get 1 byte of space. Am I allowed to yank your code and make it a library out of it? It's released under MIT, but I would also recommend that if you do, you don't copy it because, as said, it will explode your computer. Is all of this more efficient than just rewriting all of the affected API to remove breaks? This is done in conjunction with that. I did rewrite all of the API to not remove breaks. I did rewrite the entirety of the API. This process was to make it so that the breaks did not impact already released mods. Because there's nothing I could do to keep this in the API other than releasing 2 artifacts, which, as said, is not acceptable because it doesn't give first-party support to XSplit developers. How is Semver2 different from FlexVer? Semver2 is different from FlexVer because Semver2 is bad. Okay, that's all the questions I got. If there's any more, you could feel free to toss them in. I don't know how fast the system is or if it's lagging or whatever. Yeah, I've got a couple more. If it's intended to correspond to the cartridge type byte in the header, wouldn't it mean that 5 is actually the MVC2 and it just says and? I don't know how to see the rest of this. But yes, it would map to the MVC2. The fact that there was a 5 there, I never said that actually referred to MVC5. How did you test that the re-implemented API covered all of the old API? This is actually a really good question, and I should have covered it in my talk, and I didn't. So I'll go over it now. In order to create a test app for situations like this, it's pretty difficult. You can't do it with like 1 project, or maybe you can with some bespoke testing library, I don't know. Half the time I used reflection to invoke my methods that didn't exist except they did, just as a test that I was actually putting them in manually. Half the time I actually manually analyzed the bytecode of the classes I was outputting. A utility of Mixin is that it can output all of the classes it transforms. So using this, I would take the version of the 0.7.3 API, which was the last release of EMI before 1.0.0, and I would compare it to the transformed version of the Mixin API. And if there are any differences, I would have to manually test this. A way you can deal with this is by compiling an app, or a mod, or a plugin, I guess, that uses the old version of the API and tests all the things that you want to test. And then you run it with your new version of your API. It's definitely not clean, and in the future, if I was doing this at an even wider scale, I'd want to automate this system to test it more thoroughly, or in general, just test the differences between accessibility between the ABIs of Java classes. Is semver 2 better than 0 over? I don't know what 0 over is. If you can type it in chat, then I can answer this question. And the answer is also probably no. Oh, 0 over. Like not releasing or not releasing versions at all? That's a tough question. Having any semblance of order is good, but my semblance of order is really bad. So I guess that's going to be a personal preference. Oh, just incrementing. No, then 0 over is so much better. All right, I think that's all of the questions that were asked. So yeah, thanks for coming to my talk. I really enjoyed putting it on. It was fun to talk about the things that I did, and it was more fun to do them, of course, but enjoy knowing that this is running on all of your computers and is run hundreds of thousands of times. It hasn't broken yet.